Good morning, students. How are you? I think you are fine and well, doing your job properly. So we have done 9 chapters related to math. Now we will start chapter number 10. What we will start? Chapter number 10. Circle, class 10th. So we will start today. We will take as an introduction. So try to understand. If concept is clear, it's not so much difficult. If concept is not clear, then it's become difficult. So now we will start. So this is. So we know that what is this type of figure is known as circle. What's known as circle? This is the center of the circle. This is known as the center of the circle. What is this? Center of the circle. And this point name O, this A, then OA is known as OA is what? Radius. What's radius? OA is radius. What's radius of the circle? OA is what? Radius of the circle. What is that? Radius of the circle. And if you can join this become diameter. What's its become? Diameter. So this is known as the diameter of the circle. Yes or no? So this is known as what? AB. B right here. What we write B? AB is the diameter of the circle. What is AB? AB is the diameter of the circle. Yes or no? So now we can start from this. What we can start? So in this chapter, and this is known as circumference of the circle. Circumference of the circle, and which is equal to how much? 2 pi r. What's 2 pi r? And now question arises, why it is 2 pi r? So its answer also given in the previous knowledge. So this, we take a thread and paste on its boundary, or we can say circumference. So then take out that thread measuring its length. So its length is like this. We can like this, measuring this length, let x is equal to C unit. What's C unit? Measure this AB also, AB equal to D unit. And if we can find out the ratio C by D, that is always equal to pi. That is always equal to pi. Pi meaning 22, but near about 22 by 7. So C equal to pi D, and what C? Pi D equal to 2r, twice of the radius, so C equal to 2 pi r. That's why this is the circumference of the circle. Then area of the circle is also pi r square. How much? Area of the circle is pi r square. Why it is pi r square? It's also a region. That I think you know about that. So today we will start this chapter one by one. We can solve it. So look one time from this your book given. You have studied in class 9th. You have done this in class 9th. Where? In class 9th. What? In class 9th you have done that. Understood? So you have studied in class 9th that circle is a collection of all points in a plane. So this is a plane. This wall is a plane. So this is a plane, and if we can draw like this, circle is a collection of all points. What type of points? This type of points. What type of points? This type of points. So what type of point? This type of point. What type of point? This type. So what is this? So this is known as the collection of the point. Understood? Which are equidistant from a particular point. Understood? That particular point is known as the center of the circle, and this is known as the, if you can join these dots, these points, so it's become a circle. Understood? Which are at a constant distance. Which are at a constant distance. Which one is at a constant distance? So this one is at a constant distance. That constant distance from constant point to the boundary point is known as the radius of the circle. What we know? Radius of the circle. And fixed point is known as the center of the circle. You have also studied various terms related to circle like chord. What is chord? So what is chord? So chord, we can say, chord is a line segment. What is chord? Chord is a line segment which touching the circle at 2 points. How many points? 2 points. So which touching the circle at how many points? 2 points. How many points? 2 points. At how many points? 2 points. So like this we are having a circle. This is a circle. What is this circle? Circle is like this. So this is, and like this, these all are the chord of the circle. What are these? Chord of the circle. And we can say diameter is the longest chord of the circle. What one? Diameter is the longest chord of the circle. Understood? So I think you know about what is chord. You know, don't know? All of you know. Then segment. Segment also in circle. What is segment? Sector. So segment is that. First I want to tell about sector. So this is the center of the circle. What is this? Center of the circle. And if we can join like this. And what's the name of this point? O, A, B, and this C. So this complete part is known as what? Sector. What's this? Sector. And what type of sector? Sector also two type. This have taken minor arc. This, if we are taking one part of the circumference, that one is known as the arc of the circle. And complete taking, that is circumference of the circle. So this is we have taken. So this till here to here we have taken. Taken or not taken? So what we can say? This AC. What's ABC or AC? ABC, this. Or we can write AC. How can we write AC? This is known as the arc of the circle. But we have take this small, bigger one left. So this part is known as what? What? O, A, B, C is a minor sector. What? Minor sector. What is this? Minor sector. And remaining this is known as major sector. What is this? Major sector. What is this? Major sector. So understood? And how can find out the area of this major sector, minor sector? Actually, what's the area of circle? Area of circle is this, according to us. But it is not that. It is like this, 360 by 360 pi r square. Because this point is center. So taking revolution of how much? Complete taken. So how much degree angle become? 360. But both cancel each other. So that's why always saying its area is pi r square. What is that? Pi r square. So we have to find out the area of this triangle. How much formed? Theta. And this is 360 minus theta. So area of minor segment, theta by 360 into pi r square. This. Similarly of major sector, 360 minus theta by 360 pi r square. Got? So I told you about these. So you understand what is sector? Understood or not? What is sector? You understand what is arc? Understood or not understood? So what left? Segment left. What's left? Segment. This all given in your 9th class. Where given? In 9th class, but I'm repeating here. So what? So we can take this. So we are having a circle. We are having a circle. So where is circle? This is a circle. And this is known as this AOB. So AOB is known as segment. And if we are talking about minor or major, minor arc we have taken. So what we can say? Minor segment. What type of sector? Minor segment, sector not sure. Question arises. So you know this remaining, this A O dash C, A O dash C, B sorry, A O dash B is known as major. What we know? Major of this. What we know? Major. So major we have taken. So what is that? Major of that. What we know? Major segment. What we know? Major segment. What we know? Major segment. So next question arises in our mind. How can find out the area of this? How can find out the area of this minor segment and what? Major segment. Whose area? Minor and major segment. So how can you find out this? So this is the question. So we can make like this. This is the center of the circle. Where is the center of the circle? This. Join this. Join this. So this, if we can find out area of sector, which sector? O dash, sorry, take this O dash A, O B, this sector, minus area of triangle O dash A B, whose left? Area of minor segment. Minor segment. Yes or no? Got it? This we can get minor segment, get or not got area. But question is this, how can find out area of this sector? Sector again, theta by 360 pi r square. This is the radius of the circle. Understood? And minus the area of this triangle. Which type of triangle? Isosceles triangle. So its area we can find out by different ways. By different ways. If you know radius, if you know theta, we can find out this side also. Otherwise we can draw like this perpendicular on it and finding out this sides. So this, then this given, this angle given, so we know this, double of this is this, and then find out this and multiply 1/2 base into height. Different method are applying to find out the area of this triangle. So which is looking easy that you can apply. So I told you what is segment, arc, its let us now examine different situation. So in 10th class, we have taken different situation. Beta, if you want to get good marks in this chapter, so you have to must revise 9th class also related to these topics. Different situation that can arise is when a circle and a line are given in a plane. So different situation, if we are having a circle and we are having line, what possibility? So our possibility are these. What our possibilities? Our possibilities these three which are given here. Either line, segment and circle touch each other. Otherwise not touch. First case, both are not touch each other. Second case, line intersecting the circle at 2 points. And third case is line intersecting the circle at only 1 point. So let us consider a circle and a line PQ. There can be three possibilities which are given below. That I told you already. First possibility, both are not touch each other. Second, touch at 1 point each other. So if here, this is known as PQ is a tangent to the circle. Understood? And this is known as what? Secant of the circle. If line segment or line touching the circle at 2 points, then that one is known as secant of the circle or chord of the circle. And if touching at only 1 point, that one is known as the tangent to the circle. And tangent is a particular case of secant. So in figure 10.1 that already I told you, the line PQ and the circle have no common point. So this is the picture. Here look, any common point between them? There is no common point between them. So PQ is called, what's PQ called? Non-intersecting line with respect to the circle. So situation is like this. This is a circle and this is a line. So what we can say, PQ is a non-intersecting line with respect to this circle. This line not touching the circle at any point. So that's means circle and line both are not intersecting. Then taking circle in the figure 10.0, so situation is like this. Like this. This point A saying, this point B saying, line name you can say P and Q, what it may be. So there are two common points. What's common point? One common point is this, other common point is this. Understood? A and B, that the line PQ and the circle have. In this case, we call the PQ a secant of the circle, that I already told you. What is PQ? PQ is the secant of the circle. Why? Circle. Understood? Now, third case, in the figure which given in the previous page, this given, this, which one? This type of figure. Which type of figure? This type of figure. And like this, touching at only 1 point. Which point is that? A. What we are taking? A. So in the third case, there is only 1 point. Which point? A. Which is common to the line PQ. This circle and this line PQ both touching each other at point A. So which point is common? A point is common between this circle and this line. So in this case, the line is called tangent to the circle. So this PQ is called, what's called? Tangent to the circle. What called? Tangent to the circle. What saying? Tangent to the circle. And already I told you, tangent is a special case of secant. How can tangent is a special case? So look one time. So I already told, diameter is the greatest chord of the circle. So you can say diameter is the greatest secant of the circle. So look time. Look one time. This distance start decreasing between this point P taken, P dash, P double dash, P triple dash, P4 dash. So the distance, this Q dash, Q double dash, Q triple dash, Q4 dash, like this we are taking. So this distance start decreasing. What start? This distance. So PQ distance is more than P dash, Q dash. this dash, P double dash, Q double dash, and in this way. And at last, what happened? This distance start decreasing. At last, what's coming? One point coming. Both P and Q, or P dash, Q dash coming on a point. So then what's it's become? Both point meeting at a point, then this line segment become what? Tangent to the circle. So that's why this is known as the special case of secant. Tangent is a special case of secant. So in this chapter, what we will read? We will read the property. This distance start decreasing, and both coming at last coming both at a point. Then this secant become a tangent to the circle. And in this chapter, what we will read? We will read about the property of tangent. Property of the tangent. Understood? One more example given of tangent. You might have seen a pulley fitted over a well. You don't know about this, I think. This new generation don't know about this. But I want to tell, in Hindi I can tell. जो पुराने समय होते थे बेटा, उसमें क्या होता था? लोग कुएं से पानी निकालते थे. Like this is a well. And यहाँ पे इस टाइप का होता था, जिसके ऊपर से रस्सा ऐसे पानी के अंदर जाता था. यहाँ से बाल्टी वगैरह कनेक्ट होती थी, बकेट वगैरह. इसमें पानी डाल के वापस लेके इसको फिर वापस खींच लिया जाता था और पानी मटके आदि में डाल दिया जाता था. और जिस स्थान पे ये काम किया कर जाता था, वो ये जगह थी, ये मटका है. सो पुट वाटर इन इट. सो ये जो रस्सा है, रस्सा इस पुली को सिर्फ एक पॉइंट से टच करता था, एक पॉइंट से टच करता था धीरे धीरे. So this we can say is a tangent to the circle. Here showing like this. And pulley become what? Pulley become a circle. What's become? Pulley become a circle. So you might have seen a pulley fitted over a well, which is used to taking out water from the well. Look at the figure which is given here. Figure is given here. Here the rope on the both side of the pulley. So look, one time that I told you this is a rope on the both side of the pulley. Understood? One person standing here and doing like this. First time putting inside it, taking water and then taking back like this. So water coming outside in the bucket. Understood? Then putting. So side of the pulley consider as a ray. So we can think this is a ray. It's a like this. It is a rise and pulley is like this. So this touching the pulley at only one point, one particular point. So if consider as a ray, it like a tangent to the circle representing the pulley. Is there any position of the line with respect to the circle other than the type given above? You can see that there is cannot be any other type of position of the line with respect to the cannot be any other type of position of the line with respect to the circle. In this chapter, we will study about the existence of tangent. That already I told you. What we will read? Existence of tangent and property of tangent in this chapter. Also, and study some of their property. So we can start. I think you understand. If we are having a circle, and this line touching this circle at only one point. So it's meaning this line is a tangent to the circle. If a line segment or a line touching the circle at only one point, that one is known as the tangent to the circle. With respect to the circle, if touching 2 points, so that one become a secant like this. All are secant. Or we can say chord of the circle. And at last again coming here touching at only 1 point, so again become a tangent. So later on one property also. So if you are given a chord, how many tangent we can draw parallel to its 2 tangent. So tangent from the boundary also, from external point also. So from where we can draw tangent, like this we are having circle. So if you are drawing, this is not a tangent. Or tangent, not. And if we are taking this point, so we can draw one tangent this, other tangent is this. from the external point of a circle, we can draw two tangent. Understood? And on the boundary, point is lying on the boundary, then we can draw only one tangent. Any other if you are taking, so coming like this, which are not tangent to the circle, all are secant to the circle. So what's we have to tell? So we have to start it with this. Later on given this I can tell you, but today given one theorem. So what's given? Tangent to a circle is the previous section you have seen that tangent is a circle of a line that intersect the circle at only one point. That already I told you, or not told. So we are having circle, and if a line touching it at only one point, like this A, then A is A point. So then this PQ, what's PQ is known as the tangent to the circle. This saying in this point, this. Next, one theorem given. One theorem given, the tangent at any point of a circle is perpendicular to the radius. The tangent at any point to the circle is tangent through the radius of a point of contact. So saying the tangent at any point of the circle, like this is a point P. Here is this is a ray. What is this? Line. Which line? XY. Which line? XY. And what is this? Y. XY is a line which touching the circle at point P. Which touching the circle at point P, perpendicular to the radius through the. So you have to prove this angle is 90 degree. How much degree? 90 degree. So saying radius and the point of contact making 90 degree angle with each other. So this what we can take. So it's not this type of theorem not coming in exam, but we can solve it by how can. So we have taken this, like take OP. OP is the what? Radius of the circle. What's it? Radius of the circle, which touch the boundary of the circle. Which touch the boundary of the circle. So what we can say? We are taken OQ, so we can say OQ is greater than OP. OQ is greater than OP. Why? Because Q is a point lying outside the boundary. Outside the boundary. And we are having circle. One point lying here and one point lying here. This is the center. So definitely this is greater than this. So OP is less than OQ. We are taking this point. This also lying outside the boundary OQ dash. So OQ dash is also greater than OP. Region same. You can take point how much close to it, but not lying on the boundary, lying outside the boundary. So definitely it's meaning OP is less than OQ double dash, OQ dash, OQ. So how much you can take? So it's meaning OP is the shortest distance. OP is the shortest distance to reach this point. So if it is the shortest distance, then we can say this OP is perpendicular to PQ, or XY given, then XY. So this is the theorem, not so much given. If in exam coming, not possibility, but if coming, so you can say, you can take a circle. What we can take a circle? And this is the boundary. So this join this. So touching this circle at this point. So this distance, OQ OP. OP definitely less than OQ. Why? P point is lying on the boundary. P point is lying on the boundary, and this is a tangent. It's only one point touching the circle, this point. Other than this, there is no point which is touching the boundary of the circle. If not touching the boundary of the circle, it's meaning lying the outside the boundary of the circle. Understood? And if this lying inside, then become a secant. So all points lying outside the boundary. So distance of all point from the center of the circle are greater than OP. So OP is the shortest distance. If OP is the shortest distance, then definitely perpendicular distance. Like this, taking an example, I'm saying talking about this room. How much length of this room? It's meaning I'm taking perpendicular length. That one is the shortest length. If you are not taking perpendicular length, so it's meaning that one is greater than this. So perpendicular, shortest distance is always perpendicular distance. So that's why we can say OP is perpendicular to XY, or OP is perpendicular to the tangent to the circle. So this is the introduction of this chapter. Next we can start its next part. Very easy chapter. If you can understand, if you know the property of a tangent, easily you can solve this chapter in your exam. So I hope you understand this all which I told you. Next time we can start next part of this chapter. Thank you all of you. Best of luck.